Okay, we're up and running. So you saw that this week was what? You were supposed to watch that video called The Two Infinities,
Yes.
and then you were supposed to start getting into detailed review of chapter 2. And
Yes.
and even though it says did you guys get what the practice test is?
Yeah, I did it. I just couldn't do the last couple ones.
Yeah. But hang on just a sec. I just wanted to say this.
Oh.
So first of all, Leah, did you get what the practice test is?
I understand what it is. I just haven't gotten to it yet. I'm still on the ending of, I'm on exercise 2.3. I'm almost there.
Okay. So anyway, in the book there's a practice test, and it gives you it's really a lot like the test I'm going to give you.
Okay.
And I want you guys to take it and ask me questions about it, and we're going to be able to do that yet this next week before before the test that I give from Friday to Sunday.
Perfect.
So sounds like Kelsey, you're on top of it, and you've got some questions on that. We could actually do that if you want, but we will have we can do that next week too.
Okay, I can wait on those, I suppose. Should we have done any assignments for 2.5?
No.
No? Okay. Because I did see that there's some questions on the practice test regarding that.
Yeah, but the practice test, thank you for asking about that too. Okay. The practice test in the book, because I never actually taught you section 2.5, did you notice my presentation replaced section 2.5?
Yeah.
Well, therefore, the questions from 2.5 don't make a lot of sense for you. So
Right.
Here's the deal. On the practice test for chapter 2, I got to get there. Okay, the ones you cannot do are
I think just 21 through 25.
you can actually do 23 and 24.
Oh, okay.
But not 25. Yeah, just cancel 21, 22, and 25.
Okay.
Those 3 are out. But you actually could do, we can talk about those. You should be able to do 23 and 24. Yeah. So Leah, questions?
Yes.
Go ahead.
I was wondering if we could do, I know this might be a little bit farther back than Kelsey. Kelsey probably already covered this, but I was wondering if we could cover like 2.3 questions.
Yeah.
Maybe 9, or maybe question 9, maybe 9 and 19 of exercise 2.3.
Yeah.
That would be awesome.
Okay, perfect.
Those are tough.
I know, right?
Yeah.
Okay.
Okay.
This is kind of full and filled out already. We can do it separately if you'd like. But here's number 9 on 2.3. Now, 2.3, let's get the question here. So the question is A minus B union C. All right. Now, here's the diagram. This picture here on the left is the diagram that the problem gives.
Mm-hmm.
And those numbers are just this is like called region 1, region 2, region. Those are just names for those sections. Okay. So before I can do anything in this A remove B union C, I have to do B union C.
Okay.
How do you do a union? A
Um,
union is like what? Kind of join them together?
with no repeats.
Exactly.
Mm-hmm.
So let's see. Did I do that right? So B is 2, 3, 6, 7. C is 4, 5, 6, 7.
Mm-hmm.
And when you join them together, you get 2, 3, 4, 5, 6, 7.
Mm-hmm.
Okay. So now, part 2. We got to take set A and remove the answer we just found, that B union C. So A is, and this removal is a little bit weird because I know it's not quite like subtraction. I mean, subtraction, you could get a negative, I suppose, but you can't get a negative in sets. So you start off with set A, which is 1, 3, 5, and 7. Now you want to remove 2, 3, 4, 5, 6, 7. Well, there is no 2 to remove. There's no 4. There is a 5 and a 7, and there's no 6. So we remove the ones we could. What's left? Just
1.
And that brackets around a 1. That's your answer.
Got it. Okay, that one's a little easier than I thought it was, I guess. Okay.
Yeah, once you take it apart, it's really not too hard.
Could we look maybe at 19 a little further down from that?
19?
Mm-hmm.
Okay. I'll have to do 19 on the side. Let me get some space here. Okay, number 19. All right, number 19. You're supposed to draw a Venn diagram that represents that. Okay. So 19, we have all x such that x is not an element of A, or x is not an element of B. Okay, sorry, a little bit sloppy there, but I think you can see it.
Mm-hmm.
So, well, not an element of A in set terminology would be a complement.
Mm-hmm.
So a complement is what? Everything outside of set A.
Mm-hmm.
Everything not in B, that would be B complement. And here's maybe the part you didn't catch, I don't know from the videos, but what do you do with an OR? An OR is a union. And is intersection, or is union. So anyway, here's what it comes down to. A complement, union, B complement. So now we can do the picture. Okay. So we've got our universal set. We've got A. We've got B. And somehow we have to picture with a Venn diagram A complement union B. So first of all, what's A complement?
Everything outside of A.
So I'm going to do that by shading. Try. So there's everything outside of A. Okay. Now, part B, everything outside of B. Let's see. Well, let's use blue or something. Everything outside of B, and I'm going to shade that on a different angle. Whoops. So so now you've got B complement drawn in blue. Now, what's the union of those two? Well, you got to kind of throw them together.
The intersection.
And oh no, so the intersection is where the cross hatching occurs.
Mm-hmm.
But where's the union? The union is just every place there's shading. So the final answer here is all the places where there is shading. And there's really only one little section in the center that does not have any shading. So the answer to this is everything except that white part on the screen there.
Okay.
And the answer, this is how the problem is asking you to present it.
So we're giving a verbal answer for this one?
No, it would the answer would be that what I just drew, that diagram. I mean, yeah.
Mm-hmm.
So obviously I can't do that on the test because I really don't have the option to have you guys draw something.
Okay.
But anyway, that drawing is the answer. So you got to remember that. Let me just put that on the side here. So and in set talk is intersection, or in sets is union. So whenever you see an and or an or, you need to know how to you need to know right away which set operation they're talking about.
Okay.
Maybe I should just put a note on the bottom. All shaded parts is the answer to that one. So Kelsey, do you want to ask a question? Go ahead.
Can we do 27 or 29?
On that same part?
Yep.
Yeah, okay. Here's 27.
Okay.
Yeah, when is A intersect B equal to B? That's kind of a strange sounding problem. Normally A and B are partially overlapping each other, and then A intersect B would not be all of B, it would just be part of B, you know.
Mm-hmm.
But if you look at this picture, can you see how B is what? A subset of A?
Yep.
And now where do they overlap?
I guess on the inside.
Did they overlap just in where B is?
Mm-hmm.
And that's what the problem was asking. So what they were saying is, it's kind of like they're saying, here's the answer. Can you show me what the problem looks like?
Okay. So whenever there's an equal sign in one of these, it's pretty much going to be like a circle inside a circle.
Say that again.
Like when they have you draw a Venn diagram and there's an equal sign in the equation, is that going to be where there's the circle inside the circle where they intersect?
Well, if it's just a simple something intersects something, yes, that would be true. But there's a lot more kinds of problems that can come up with equal signs, so I can't just give you an unqualified yes.
Okay. Well, I mean, like in these types of set problems with Venn diagrams.
One letter intersects another and it comes out to one of the two.
Mm-hmm.
Yeah, the one it comes out to has to be in the inside. Yep.
Okay.
In that case, that's true. Yeah.
Okay. Oh, I do have another question for 2.4, number 5.
Okay, we're going to have to do that one, which is fine. Let's see, 2.4, number 5. Let's do that right here. Okay. 2.4. Number 5. Oh, yeah. On checking with 100 families, it was found that 75 families subscribed to Time, 55 to Newsweek, 10 to neither. How many subscribe to both? Okay. So we're gonna solve this using sets.
Okay.
So I am going to pen first. Okay, so Newsweek and another circle representing Time. Okay. Now the key here is you need to do both first, even though it's not the first thing mentioned in the problem. If 10 subscribe to both, I'm going to stick a 10 where the two of them overlap. Okay, now.
Isn't 10 who subscribe to neither one of them?
Oh, yeah. I read the problem wrong. Thank you.
Because that's where I was confused, because I couldn't figure out, because if I could have figured out what the middle was, I could have then been able to find out.
Well, we'll show you how to do it.
Okay.
Okay. Sorry, I read the problem wrong.
That's okay.
Okay. So 10 subscribe to neither. Those 10 are out here. Now, it says 100. There's 100 families, and you notice they give you 75 and 55. Well, 75 and 55 already add up to more than 100. Okay, and what do they add up to? What is 75 plus 55?
130.
And that really should only add up to 90 because we've already got 10 taken care of outside. So we really have 90 families left.
Right. So
what's the excess of 130 versus 90? 130 over 90 is how much over?
40. Right?
Yep, and that just told us that. Now.
Oh, okay.
I'll just show you. So let's just finish it out now. 75 subscribe to Time. So if I put 35 there, now I've got 75 in the Time magazine circle and 55 to Newsweek.
Okay.
Now, if we add them up, we still should get 100. 55, 90, 100. There's your picture. Now the question, now you can answer the question. How many subscribe to both? Well,
Right.
it's 40.
Okay.
Yeah. So whenever you have an excess like that, that is a clue as to what the overlap is.
Gotcha. Okay.
Okay, Leah, why don't we take turns? You're back at it again.
Okay, perfect. Let's see, let's do, and the same question, 2329, the one after the question Kelsey asked.
Number 29.
Yeah, 2329. I was having a tricky time with those two.
Okay. Yeah, well, I've got the picture drawn there.
Okay.
Let's see. All right. So on number 29, I got to go back to that lesson.
Because I really think the book doesn't describe it too much either.
Yeah. And this is really a thought question. So just look at the second part. I mean, just cover up. Well, here, I'll just write it out. All right. I got to find some space here. Here we go. Okay, I'm just going to look. Here's the whole problem. A intersect B. And the answer is supposed to be A. Okay, let's just let's just do this part first. Now, very similar to the one I just showed Kelsey a few minutes ago. Do you remember when we did A intersect B is B? Mm-hmm. And like Kelsey spotted, when you have two things combined and they equal that thing, that means that thing must be on the inside, right? Mm-hmm. Yes. So just looking at the underlined part, doesn't that look like this? I mean, just take a look at these two circles. Where do they overlap?
In the center.
Yeah, and at A. Okay. Mm-hmm. Now, I know I ignored the first part, but now that you know the answer to that part, all right, where's the overlap? It's
A.
I mean, it's just A. Okay, mm-hmm. So now what it's really saying is, what's A intersect A? Because this part is just A, right?
Yeah.
Mm-hmm.
And what's A intersect A? I mean, this is the picture. So you were supposed to, again, answer with a Venn diagram. This picture that I have drawn in the center of the page, that would be your answer. So on this descriptor here, I just put it right here. See how B is outside of A?
Yes.
Yeah, that's the answer we just got over here.
Got it. Okay. So is that similar to 31 following, or is that a different type of question?
So there's a case where they're telling you what's different about 31 is they're saying this thing is true.
Mm-hmm.
Can you demonstrate it for me? Okay, so here it is. I mean, it's going to take a while, but in the first part, I'm doing the left side.
Okay.
Part 31A. See how this is the left side? A union, B union, C.
Yes.
Okay. Now, what's A? Look back to the diagram. Unfortunately, I don't have room for the diagram here, but A is 1, 3,
1357.
Yeah, 1, 3, 5, 7.
Mm-hmm.
Okay, now do the union of B and C. And that's this 2, 3, 4, 5, 6, 7. It's just B, all the numbers in B and C. 2, 3, 4, 5, 6, 7.
Okay.
And then when you do the union of A, which is right here, and the B union C, you get this answer. Okay, then I got to show that the right side comes out the same way. So you got to go through the horse and around, but this time you have to take A union B separately, and then do a union with C. And anyway, the bottom line is this answer comes out exactly the same as that one. So,
and they're exactly
so there
the same.
they're saying, hey, we're telling you this is true. Can you kind of prove it to me? And that's what that would look like.
Got it. I guess I find these problems a little easier where you can actually write things in notation versus.
I agree. I think those, honestly, I think the ones that you guys asked, numbers 27 and 29 those are pretty tough. Those are maybe a hair over the top. They're kind of thought questions. Yeah. You're right. These are a little bit, I like these better too. You can show point by point how they work. Yeah. Yeah, any of those others in that 30s section you wanted to ask about? Like, what did you get 33? Did that make sense to you?
Somewhat.
I mean, think about it. A is everything in A. A complement is everything outside of A. What happens when you join those together?
See.
You say everything in A joined with everything outside of A. It's kind of like you get everything, right?
Mm-hmm.
Yeah, and look at what the answer is. That universal set. That's the set way of saying everything. Okay, that completely puzzled you, I can tell. All right. When, you know, like what here, if you look over at this problem on the right here, I've got these circles, and then I put this big box on the outside and I label it U.
Yes.
That's like the universal set, everything.
Okay. Mm-hmm.
And that allowed me to name these 8 that are on the outside over here.
Okay.
Okay. So what we're saying is if you take everything inside a circle, join it together with everything outside a circle, you're going to get the whole box. You're going to get.
I got it. I was thinking intersection. Got it.
Yeah.
It has to be union.
You're right. Intersection. And by the way, what happens when you intersect them?
If you have A and you intersect it with a complement.
Yes.
So you would have, I mean, a complement would be everything outside of it, but then I'm not sure actually.
Okay, so look, I mean, in effect, here's how it works. Everything in the circle, all right, then you got everything outside the circle. What's in common between those two? Answer? Nothing. right?
Yes, because they're completely different.
Exactly. And so the answer is bracket, bracket. We call that the empty set, which is a fancy way of saying nothing.
Okay.
And now I actually did an example here where I took everything in the set. What does it have in common with everything outside of the set? Absolutely nothing.
Got it. Makes sense.
So anyway, I thought we'd just talk about those a little bit because I know that sounds like it's kind of silly, but those are actually pretty important problems. So, Kelsey, back to you again.
Do you think we could go over, I know it's a little bit ahead.
The practice test? Sure.
Yeah. Could we go over those, the cardinality of the sets, like on 23 and 24?
Yes.
Okay.
Okay. So, here's 23. I gotta find the practice test first. Okay, yeah, fine. All right, so do you get the set they're talking about there? 1, 4, dot, 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 n squared, dot, 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 144. Do you get what that means?
Well, I know the dot, dot, dots, you have to keep going.
Correct. So, and you probably are wondering, what's that n squared doing here?
Yes.
Okay, that's actually telling you what the pattern is. So, n is whichever number you're on. So when you're on the first number, 1, what's 1 squared?
1.
1.
Second number, 2, what's 2 squared?
4.
See how that's what it is?
Gotcha. Okay.
What would be the next number? When n is 3?
9.
Yeah. And so it's saying, keep doing that until you get to 144.
Okay.
Now, can you tell me what number, if you follow that pattern, which number are we on if it's 144?
12.
Exactly. So what's the number of elements in set A?
Gotcha.
12.
Okay.
Yeah, that notation is a little bit weird to get used to. But that's all that n squared is there. That's saying, hey, just in case you can't tell, here's what the pattern is.
Okay.
And n is, which number are you on? Are you on the second, the third, the fourth? Yep. So 24. Now, what's different about 24?
24, it doesn't have like the n number. It just keeps going.
Yeah, which means that thing goes on forever, right?
Right.
So how many elements are in that set?
An infinite number?
Bingo.
Okay.
Yep, all because of that one number that's not at the end.
Okay. Cool.
Yeah, and thank you for picking those up, because those are, like I told you, those are two of the problems from the practice test that I'm thinking you should be able to handle those.
Okay.
Yeah.
Mm-hmm.
Do you have another question?
I do.
Okay.
Let's do. Can we do, I know this is going a bit back, 22, 21. It has
When you say
that.
22, you mean 2.2?
Yeah, 2.221.
Okay. Yeah. Okay. Gotta get my book back there. So I've got it done here on the screen.
Okay.
Yeah, and this is where they gave you sets. So you have to look at the paragraph above.
Okay.
So you see how up above they tell you that the universal set is A, B, C, D, E, F.
Yes.
And then they tell you set A is A, C, E.
Mm-hmm.
So in the problem, when they ask you for A complement, you got to figure that out. What would that be?
Okay. And then I'm gonna look at the universal set that.
Right.
Okay.
And what is it? What's outside of A?
B, D, and F.
Correct. So you see I've got that up there on the left.
Mm-hmm.
Okay, now what's in set B? Well, I just copied that right from the book, B, D, E, F. Right?
Yes. Mm-hmm.
And now we have to do this intersection thing. What do you do with intersection?
Find what's common.
Yep, and what's common between those two?
B, D, and F, excluding E.
That is correct. That is the solution to number 21.
Okay, that one's easier than I thought. Okay.
Yeah, there's sometimes you're like, well, of course it's B, D, and F. You know, some of them are pretty obvious. Some of them are a little bit deeper. Yep.
Got it. Thank you.
You're welcome.
If we had time, could we do 2.42? I think I'm on the right track with those. I just want to make sure I understand I'm doing it right.
2.4, number 2?
Yeah.
Yes. Okay, 2.4, number 2. It says, suppose that the number of elements in set A is 12, the number in set B is 6, and the number in A union B is 14. Can you tell me what's in the intersection? So this is similar. Remember the Newsweek time problem we did earlier?
Yes.
Yeah, this is a lot like that. Let me, here, I'll just draw it over. So you've got, whoop, let's get a pen. All right, you've got A, B, the number of elements in set A is 12, but I don't want to draw that in yet because A is in 2 parts, and I don't know where to put. But the one thing we can draw in is this part. The number in their intersection is 4. So I would start by putting that 4 in there. Now, if A has 12 in it, what do I need to draw in?
Where I know the 4 is on that sheet there. I'm just having trouble. Where's the 4 in the question?
It's right here.
Find an interest.
Oh, maybe I'm reading the question wrong. Where are we?
No, that's okay. I think it's on this piece of paper you're showing me, but not the one that I'm looking at.
Oh, it's not. Okay, I'm sorry. I
That's
wrote
okay.
that on, but I'll show you how to do it. Okay, so let me erase that. Okay, so A is 12 and B is 6. What happens when you put 12 and 6 together?
You have 18.
And what does the book say we should get when we do the union?
14.
Now, do you remember how I told Kelsey when you have an excess like that?
Do you subtract the difference?
Yeah. So that we know the answer is 18, and yet they tell me the union is 14. What's 18 minus 14?
4.
That's where I got the 4.
Got it. Okay, perfect.
And then you know how to go from there, right?
Mm-hmm. Yeah.
All right. So, yeah. So I'm sorry. This part was not on that 4 that's up there was not on the actual question. Yeah. So you get that by 18, but it's 14. We're off by 4. That must be the overlap.
Mm-hmm.
Yep.
So it says find A intersection B, and your answer would just be 4.
That is correct. And that's what I was right. That's why I wrote it on the screen.
Got it.
It's an answer, not a question. Yeah. Okay, I got a text message from somebody. Oh, don't have to answer that, right? I thought it might be a class member. It's not.
I have a question on the practice test again.
All right.
Number 2. So it says the counting number between 2 and 10. So you don't include 2 and 10. You just do what's between them?
That is correct.
Okay.
So that would be what? 3, 4, 5, 6,
3, 4,
7, 8, 9?
Yeah.
Yeah.
I just put on my answer, I put like 2, 3, 4, 5, 6, 7, 8, 9, 10, but then I looked at my answer and then I'm like, oh, okay, I guess I don't have to include those ones.
Yeah, technically in mathematics, when we say between, we don't mean the endpoints.
Okay.
Yeah.
And then on number 5, on the practice test on D, I was just confused by that one, I guess.
Okay. So you're supposed to fill in the blank with an is an element or an is not an element. So here's what they gave you to fill in. A remove B equals all x such that x blank A and x blank B complement. Okay. So if you're going to do A minus B, you got to start with everything in A because that's kind of like your beginning point. So that one probably I'm guessing you're okay with, right? Is an element?
Yep.
All right. And now and which in sets means intersection. A what? Is an element of B complement? Because it's mine, yeah, that was a tough one. But because it's B complement, it's everything is in B complement. Because I mean, you know, yeah. Here, let me just show it to you this way. I'll try to demonstrate it by doing a drawing problem here.
Okay.
See if I can find some space. So what we want to show you is that A minus B is the same as because here was that and then they said everything is an element of B complement. So in effect, they're saying the problem is really saying this. Now, just to convince you of that, on the left, what does A remove B look like?
Yeah, everything without the intersection.
Like that, right?
Yeah.
Yep. Okay, now on this side, what does this look like? Okay. A, B. Okay. Now this is an and, so this is an intersection. All right. So,
Yeah. So
here,
I guess the
so-
same plus everything outside the circles.
so first there's A. Okay. And now I got to do B complement. Let's find out how bad I am at drawing. And where do the red and the blue intersect?
Basically the same as the other one.
That's what I'm trying to show you.
Okay.
Yeah. And so that was a little bit deep, but what they're showing is, oh, if those two are the same, then we could say it, in that D way. We could say, all right, I mean, by the way, if they'd have put a B here, then it would be X is not an element of B. But because it was a B complement, it's X is
an element. Okay.
So that one was a little bit deep, but
Mm-hmm.
we just kind of showed you that they do really come out the same. Good questions. I can tell you really got into the practice test. That's good.
Mm-hmm.
Leah, I can tell you're ready. Go ahead.
Okay. I have, let's see. Let me turn to it real quick. 2-4, number 1. I just wanted to make sure that I'm thinking about it. It's pretty easy. I just want to make sure it's kind of like what we had before, but they're subtracting something there.
Okay, let me take a look. 2-4, number 1. Number in A is 15. Number in B is 20. Number in A intersect B is 5. Find the number. Okay, so here, let's just do it over.
Okay.
Right, so number in A is 15, but I can't really draw it in yet because there's 2 parts. Number in B is 20. I can't really draw it in yet because there's 2 parts.
Mm-hmm.
You know what I mean?
Yeah.
I wouldn't know quite where to put the 20. Do I put it over here or do I put it, you know what I mean? Okay.
Yeah. Mm-hmm.
But then they give you that third clue. The number of elements in the intersection is 5. So that's a big one. Now I know that I can put a 5. I got my thing stuck there. Now I know I can put a 5 in the middle. Now go back. If A has 15, that means the outside part of A must have 10. If
10.
B has 20,
15.
now what's the number of elements in the whole union? The sum of those.
30.
10 plus 10. Yeah, exactly.
Mm-hmm.
So you probably noticed that's kind of a theme. I think that's
Mm-hmm.
that kind of problem has come up 3 times tonight. That's a pretty important thing. Yep.
Got it. No, perfect. Got it. Mm-hmm. Could you explain maybe 2229?
Yeah.
Thank you.
2.2, number 29.
Yeah.
Okay, so that big fat, oh, it looks like a 0 with a slash through it. That's the symbol for the empty set.
Okay.
And with a apostrophe on it, that means what's the opposite of. So in effect, what they're saying is, what's the opposite of nothing?
Everything.
And how do we write everything in sets?
Universal set?
Exactly.
Okay.
Yep.
So just think an opposite.
That's a good way to think of complement, yes. Outside of or opposite.
Okay, good. Could we do possibly 2325? I know we did one similar to that one.
Okay, so I've got it done, but I'm going to have to do it over. Okay.
Okay.
So the first thing I'd like you to look at is at the very top. That's the problem in the book, right? That X such that X is not an element of A and X is an element of B and X is an element of C.
Mm-hmm.
So we got to do the parentheses first. X is in B, X is an element of B. Well, that's just, here's the, in red, here's the translation of that into sets. Okay. It's in B and in C. Remember, and means intersection.
Mm-hmm.
So here's the set of parentheses down below. That's just the same. Everything in B and intersect everything in C. So B intersects C.
Okay.
And then the beginning part is X is not an element of A. Okay, that's a complement. And again, it's the word and. So you notice. All right, so that's step one is, could you come up with that statement in the box? And now that you've got the statement in the box, then we can make the Venn diagram. So I'm going to move over to the right here a little bit and we'll do it. Did you get that written down?
Yeah, I just got it done.
Okay, so let me move it over just enough so I can see it. Yeah, I'll try to draw it small enough. All right. So we need 3 circles, A, B, and C.
Mm-hmm.
Let's undo that. A pretty sick circle. There we go. We got our A, B, and C, and we got a universal set around it. So what do we have to do first in this thing way at the top of the screen? We got to do B intersect C. Where does B overlap C?
B overlaps C in that small circle in the middle.
Wouldn't it be in this little football?
Yep. Mm-hmm.
Isn't that where B and C overlap? Okay. Now, so part 1 done. Now the question is, where does A complement overlap that? So now I got to draw A complement. So I'm going to pull out my, let's go to, I don't know, green or something. A complement would look like this. Everything outside of A. So the question now is, where does the green overlap the black?
The green overlap the black in that little football spot.
Not it, just in this part outside, like here, right?
Oh. Mm-hmm.
And that would be your Venn, that would be the Venn diagram of the solution. So the answer is that part in there. I need another color here, but so answer. You don't have to write this, but I'm just doing it so that you can really see that the answer is just that little green section there.
Okay, perfect.
Or you could have just said where the green overlaps the black, you know, something like that. Yeah.
Okay.
Well, you guys made this into a session just like I want it to be. You guys are very good. Thank you for asking excellent questions.
Yeah.
Thank you.
Thank you for answering them.
I can tell from your questions that you guys are really digging in, and that's going to make it work for you. You're going to do fine.
Well, thank you very much.
You're welcome. So I guess let me just add this point. The notebooks. Did you see how to hand those in?
Yep.
I didn't have this in the beginning, but if you go back to week 3, that's this week, right down here, you'll see it says notebook 2.
Mm-hmm.
And if you click on that, I mean, it's different when I click on it. It tells me as a teacher how many people have handed it in. But when you click on it, yeah, it just shows me that of the 11 people, nobody's handed. Okay, it wasn't due yet. But when you guys click on it, it lets you put a file in there.
Mm-hmm.
Yep.
So the idea is you're going to take your pictures or your scans and you're going to put them in, I don't know, maybe Google Docs or a Microsoft Word document. And then you can put that document into that folder and you will have handed in your notebook.
Okay.
All right. And I wanted to tell that to everybody, and only 2 of the 11 are on board. I think part of the problem is the adult students are many of them are taking another class on Thursday nights.
Mm-hmm.
I take mine on Monday, so sometimes it's hard for me to go in the chat
So you can't get in the chat. Yeah,
Yeah.
I'm sorry about that.
No, that's okay.
Yeah, but you can at least look back at, yeah, it's not ideal, but it's good that one of them works for you, because then, like, you know, you can come in here and we can talk all you want.
Right.
Good.
Perfect.
Well, good night, ladies. Have a good evening.
Thanks.
You too. Thank you.
Bye.
Bye.